Team Introduction. Hello, we are Rice Raven Store number 18860, an FTC team. We are all 6th, 7th, and 8th graders from Rice Middle School. You can find more about us on our website. The link will be posted in the chat. Hi, I'm Ishrit, and I'll be talking about the FTC introduction and programming. As you will see throughout the presentation, each person will talk about the part of FTC they worked on. Other team members will post helpful links in the chat and answer any questions you have. Each team member will have their name and _Ravenstorm Robotics so you can easily identify them. Each team member will also have a storm background with our logo. Questions. If you have any questions during the session, feel free to unmute yourself or type your answer in the chat where one of our members will help you. If you wish to unmute, please be mindful of the speaker and ask once the speaker has finished talking. What the camp is about. This camp's goal is to give you an in-depth look into FTC. It is an advanced version of the video we released earlier this year called The Basic Concepts of FTC. The link to the video will be posted into the chat if you want to check it out. Presentation contents. These are the topics we will be covering over these 2 days. Please note that these contents are subject to change based on time and team decision.
Now we will move on to the team, camp, and basics introduction. First Tech Challenge, otherwise known as FTC, is a robotics competition for students in grades 7 to 12 to compete head-to-head by designing, building, and programming robots to compete with each other. FTC stands for First Tech Challenge, and it's an event created by the nonprofit organization FIRST with the goal of getting the youth involved in STEM activities. If you have participated in FLL, also known as First Lego League, you have participated in a FIRST event. There are a few more programs for different age groups, but the one we will be discussing is FTC, which is for those in grades 7 to 12. FTC seasons operate on a yearly basis. This means that every year there is a new FTC season, and each season has a new challenge. Challenges are essentially games that the team must create a robot for to score as many points as possible. These challenges are not simply easy, and are like full-fledged sports. Gracious professionalism is part of the ethos of FIRST. It's a way of doing things and encourages high-quality work, emphasizes the value of others, and respects individuals in the community. With gracious professionalism, fierce competition and mutual gain are not separate notions, but rather combined into a better, more fun, and exciting form. This applies to every FIRST challenge or league, and it's what makes FIRST events great. The essence of STEAM can be found throughout all of FTC. STEAM is an acronym standing for science, technology, engineering, art, and mathematics. STEAM is incorporated into FTC in many different ways. Science can be found when understanding the physics of the robot game, which directly affects how to design and incorporate your team's robot to get a higher score. Technology is used when choosing what materials to use in a robot and when coding it as well. Engineering is used when learning how to physically design a robot to best incorporate the factors of science. Even though robotics doesn't seem to include art right off the bat, once you look closer, you will see the art aspects of FTC. The design award is judged based on how aesthetically pleasing a robot looks, also contributing to the tasks the robot should accomplish. Art can also influence the engineering hurdles of creating a robot. Math is found in all 4 of the above values and determines everything from the shape of the robot side face to the torque ratio when using servos or gears. And it's all right if you aren't good at a specific part of STEAM. Working as a team allows players to share their benefits, which in the end helps teammates do much more than if they were working alone.
So now we're going to move a little more in depth into the game, how the FTC game works and how advancement works. So each challenge, like we were talking about before, is kind of like a full-fledged sport. And so the team will have to create a robot for that. So each challenge will have different game elements, and game elements are just what's used to score. So in Ultimate Goal, which was this season, or well, last season, we used these rings and these wobble balls. And then in the season before that, it's called Sky Stone, sorry. We use these yellow blocks. And so because of that, different parts of the robot would have to be developed for different things. So because of this, each game will require different design challenges to be conquered. And so, new mechanisms will have to be created each year. The game itself is 2 minutes and 30 seconds, and it's divided into 3 parts with 2 alliances, red and blue. And so alliances are just teams of 2. So when you're actually playing the game, whatever season it is, it's going to be teams of 2 versus teams of 2. A team of 2 versus a team of 2. The actual split up of the timing is like this. So the first 30 seconds of the game is called autonomous. And so in that period, the robot will only go on pre-programmed commands. And there are usually tasks you can only do in autonomous. In addition, after that, you have driver controlled, and driver controlled is 2 minutes. So if you notice before, I said there are 3 different parts, and the game is 2 minutes and 30 seconds. So the first 30 seconds is autonomous, the next 2 minutes is driver controlled, and the third part is called endgame. And endgame is just the last 30 seconds of driver controlled. And usually there will also be more ways to score for extra points. And so and in driver control, you'll control the robot with a controller. And to do this, you create code for the robot. And I'll talk a little more about how that's done in day 2 of this camp. And now I'm going to move on to the advancement. So if you don't know, FTC has an advancement procedure similar to like science fair or history fair. So in North Texas, that starts with qualifiers, then to regional championship, the state competition, and then the worlds. So events will have different number of teams advancing on an event, on a per event basis. So however, like while the number of teams who advance changes, the order of advancement, aka who is the first to advance, the second, third, fourth, etc., is the same across the board. So on the slide, I put like the first 10, and this list goes on to like 50 or 60. And that's just because some events may have like 200 teams, some events may have like 30 teams. And so that's why it's different. So in an actual event, if there were 30 teams and only 6 could advance, then the way this would work is the top 6, and the top 6 is determined by this. So whoever Inspire Award 3rd place, winning alliance, and like I said before, the alliances are just the winning team essentially. So the Inspire Award is an award, and we'll talk more about the awards in the engineering notebook section. This optional award, it's essentially for whichever team, the team who's hosting the event, they'll essentially automatically advance. But in North Texas, at least, we haven't had that. And so depending on which region you're in, you may or may not have that award or advancement, sorry.
So now we're going to move on to the engineering notebook, portfolio, and awards. So these are all the awards as of the 2020 to 2021 FTC season. So note that you can get first, second, and third place in all of these awards except the judges and the Dean's List Award. So the first award is the Inspire Award. This award is the most prestigious award an FTC team can receive. And getting it means certain advancement due to the order of advancement table we looked at earlier. So basically, the Inspire Award celebrates a team's positive influence on their community, and all around, the best team in general will receive this award. So the next award is the Think Award. This is the award that relates to engineering content. So for example, you could have CAD, coding, building, and programming. The Think Award is awarded to teams that best demonstrate these aspects of the engineering design process. So the next award is the Connect Award. This is a team's outreach to technical communities. So technical communities would be kind of like big corporations such as NASA or SpaceX. And outreach is a team's connection to their communities. So basically the Connect Award would be awarded to the team that connects to their technical communities the most. So the next award is the Collins Aerospace Innovate Award. This is an award the judges award a team that documented how they met a challenge and how they reached their design solution. So the next award is the Control Award, sponsored by ARM Incorporated. So this award celebrates a team's control over its robot. In specific, it's related to sensors. So some examples could be color sensors or Logitech cameras. The next award is the Motivate Award. This is the award that relates to non-technical outreach. So non-technical outreach would be, for example, students or schools. The next two awards are very similar. They're the Promote and Compass Awards. So these are both optional, and that means they're not given at all events. So all the events we went to this year, none of the teams there got one of these awards. So to get one of these awards, you have to submit a video. I don't know the exact guidelines, but they're on the first website. So the next award is the Judges Award. This is also optional and not given at all events. So the Judges Award is an award the judges award a team that they feel should get an award, but aren't a contender for any other awards. So the last award is the Dean's List Award. So this is the only individual award a FTC member can get. So this is for 10th and 11th graders. And to be a contender for this award, your coach has to nominate you based on your influence on the community. You can think of the Dean's List Award as kind of like the individual version of the Inspire Award.
Arnav, you are muted. You might want to unmute.
Oh, sorry. Wait, where was I muted?
Starting of the slide.
You're on the engineering notebook, the
okay.
slide after the awards.
Oh, okay. So, sorry for that. So an essential part of FTC is the engineering notebook, which includes aspects like the design process, testing, research, etc. You can think of the engineering notebook as kind of like the science notebook in science fair. Like in science fair, it doesn't seem important, but it very much is. So in science fair, usually if you don't submit a science notebook, you can't get an award or you can't advance. It's applicable to FTC too and has the same concept. So the engineering notebook is where you document every single thing you've done in the season, whether it is building, programming, or CAD. So it is used for teams to advance to next levels of competition through awards. So this helps newer or less advanced teams, such as rookie teams, to have a fair shot at advancing because they don't need a really good or functional robot to go to the next levels. So many engineering notebooks have a team introduction, biographies, designs, pictures, and daily logs. They're long and very descriptive and detailed. They often hit hundreds of pages. So these are the 3 requirements for the engineering notebook. So teams may not present more than 2 notebooks at a competition. So this is more applicable for face-to-face competitions when you had to actually go face-to-face to do FTC. Obviously that couldn't happen this year because of the COVID-19 pandemic, but it's still the same. Basically, like they have this requirement because like you put it in a binder and there's only you can't make a binder that's super large. So like judges don't want to go through thousands of pages. That's what it's trying to restrict. The team number must appear on the outside of the engineering notebook. So some teams like to get fancy with this and they like to 3D print their team number. This isn't required, but you need to have their team number in some shape or some form on the outside of your engineering notebook. So teams should attach a 1 to 3 summary page or pages, which is kind of similar to engineering portfolio, which we will do later in the presentation, to the front cover of the engineering notebook. The summary page should include a brief narrative of the team, school, organization, which directs the team, with highlights of the team season. So highlights would be awards a team received or outreach events that went really well, or generally just anything their team is especially proud of. It should include the team number and tab the most important pages in the engineering notebook. So it is essential that you tab the most important pages in the engineering notebook because judges only have a few minutes to shift through hundreds and hundreds of pages. And you want to make sure they've seen the pages that will get you, qualify you for awards. So this is the first part of the engineering notebook. So this is the team introduction. It generally consists of 2 subsections. So the first subsection is the team objectives. In this subsection, you have to give basic information about your team and your goals. You have to include the team name, practice times, and frequencies, and how you've either improved or changed this year. Then other subsection is individual biographies. In this subsection, each member of the team, official or unofficial. So if unofficial members would be like apprentices, mentors, or shadows, will include a short summary of their autobiography. So things that members include in their autobiography are their name and age, a picture of themselves, then they include their main job of the team, whether it is building, programming, CAD, or outreach. Next, they will include their hobbies and any extracurricular activities they're involved in. For example, if they're in soccer, they would put that, or if they're in orchestra and they really like violin. Also, make sure that you include your reasons for joining the team. So reasons for joining the team could be your interest in robotics, or you want to participate in STEM. So a page from this section of the engineering notebook shown below. This is our Who We Are page, and this is one of the team objective subsections. So this part of the notebook is very important. This is the designs, pictures, and course of action. It is oftentimes the main part of the notebook. It's very important because it qualifies you for awards. Nearly every single award depends on this section. So common things to include in this section are CAD and robot designs, which we will be showing you later in the presentation, pictures of the robot, and a plan and course of action for the season. An example from this part of the engineering notebook is shown below. This is our one of our intake mechanism slides, and this is one of our pictures of the robot. We were showing how we were using baby hands to put in the rings. So the last section in your engineering notebook is the daily logs. So they record down plans for the day and what was actually accomplished. So if done correctly, daily logs can help qualify teams for awards. Each member of the team puts down their individual accomplishments or what they did that day. An example from this part of the engineering notebook is shown below. So as you can see at the top, it lists the date. This was our second daily log. And then it lists the plan for the day. So for each aspect of FTC, what's your plan to get accomplished. And then lastly, it outlines what each member did. So these are just some various pictures from our engineering notebook. So the first one is our team name survey results. We were picking our team name, and as you can see, Ravenstorm won. And then the last three are just various CAD pictures our team made. So as we said earlier, the engineering portfolio is an overview of the team and its work. So it includes summary of engineering content that includes robot design processes. So robot design processes would be, for example, building or CAD designs. It also includes summary of team information that includes information about the team and its outreach. We've done outreach earlier. Summary of the team plan of information about the team overall. So plans could be business plan, fundraising plan, a strategic plan, or etc. So these are the two requirements for the engineering portfolio. So you can think of the engineering portfolio as a super compressed version of the engineering notebook. The reason for this is because it must not exceed 15 pages, because the judges look at the engineering portfolio before the interview, so they have a kind of a hint about who your team is and what questions they ask you. The control award submission form, which is a form you submit to be considered for the control award, is not part of the engineering portfolio and will not count as one of the 15 pages. The title slide is also not counted as one of the 15 pages. However, if you do include a table of contents, that is counted. So the team number is strongly recommended to be at the top of the page, but you should treat it like it's required. So these are just some various pictures from our engineering portfolio. So the first one's our table of contents. Second's our second prototype of our robot. Third's the autonomous period in programming. We'll be talking about this later. And we're also going to be talking about teleop and driver control of programming later. This shows what buttons on the gamepad do what. So before we start the KAHOOT and later CAD, does anybody have any questions? You can unmute or type your questions if you have any in the chat.
Hey, one question is, does that engineer book provide some base design of robot? So, for example, for the new team, right, first year team,
Yes.
they can. Okay.
No, sorry. I was just saying yes to your question. All right. So basically, the engineering notebook is where you put down everything that you're going to do in the season. So for new teams, there's a great resource. It's called Game Manual Zero. I'm going to put the link in the chat. So this has basically like all the information a rookie team or a starting team could ever hope for. We use this ourselves, yeah, like it's a really great resource. I put it in the chat.
Okay, thank you.
No problem. Does anybody have any other questions? Okay, I think we'll start the KAHOOT then. So now we're going to play a KAHOOT to test your knowledge on the introduction to FTC engineering portfolio and the engineering notebook. So go to kahoot.8 and wait for us to screen share the code, then join the game. So login. Okay. Okay, so yeah, here's the code.
If you would like to join, please go to kahoot.it. You can press enter and then enter the code. Please also choose an appropriate nickname.
Yes, please keep this family friendly. Thank you. Also, I would help if you turn off your camera so to reduce lag.
Hey, Robotics, turn off your camera, please.
Okay, I'm gonna at 3:31 we'll start. Okay, I think we'll start now. Okay, so most of you got this right. It actually stands for First Tech Challenge and not First Tech Competition. You might have gotten confused with FRC for the competition part. Good job to your mother and grandma. Okay, good job. This was like a trick question for those of you who clicked 7 to 12. That was grades. The actual age is 12 to 18. So the ethos of first is gracious professionalism. Yeah, these answers were pretty close. So good job for those of you who got this right. So most of you got this right. Remember, we said that the title slide nor the control award submission form is counted as one of the 15 pages. But good job. So this one had two answers. So Java so remember, daily logs are for first making plans for the day. So you first make plans, and after the day is over, then you record down what you did this meeting. So good job. Most of you got this right. Good job. All of you got this right. Yep. Everything in the engineering notebook is important. Even though the designs and pictures are the main part of the notebook and they're what gets you awards, everything is still important. To have a good notebook, you need to have everything. Okay, so engineering notebooks are lengthy and detailed because remember, you're documenting every single thing you've done. So yeah. Let's see who's winning now. It's been quite a while. Yeah, your mother is still in the lead. Good job, your mother. So remember, the engineering portfolio is a super compressed version of the engineering notebooks. So basically, the engineering notebook would probably include all of these things, including the team favorites, maybe. But remember, the engineering portfolio is super compressed. So you only need to put what you only want to put what is absolutely necessary. But good job. And your mother is still in the lead, but Anonymous is catching up. To the second to last question. Okay, so the answer was 15. Maybe you might have gotten confused with the engineering notebook, and that's why you put maybe 67. But yeah. Oh wait, 15 people responded in 15. Haha. Okay, Anonymous is still on top, but it's 700 points behind. This is the last question. And correct, the team number is what's supposed to be at the top of every page. Yeah, this was pretty close. You have to look out for the last one. And yeah, this is included. All of these things would be included in our case, but what is recommended to be top of every page? That would be team number. So now let's see who did the best. Third place is Candace. Good job. Anonymous, good job. And our winner is, drumroll please, your mother. Good job to runners up too. All right, so now we're going to go to the CAD section of the camp where we're going to show you how to use Tinkercad and also show you CAD.
Okay, so now, as we said previously, we'll be moving on to the CAD section. So computer-aided design, or CAD software, is used to assist in the design process. So what it essentially does is it allows you to design something in a 3D space on the computer. So in the real world, this is used for things like industrial design, architectural design, and like many other fields. But in FTC specifically, this is used to help design the robot, and it can be used to create custom parts, which can then be 3D printed or milled by a CNC machine. CAD software helps the team plan out the robot design, but it should be noted that CAD software is not necessary for successful robots. It is entirely possible for your team or you to completely build a robot ground up without any CAD, but again, it is recommended. So some teams may CAD their whole robot or only certain parts, and others may not at all. It does, however, help find design flaws and remove headaches in the design process.
Okay, so to help you guys get the idea of how CAD software works, we're gonna do like a Tinkercad tutorial. So Tinkercad is like a very basic version of CAD. It's a very basic software, and so it's really easy to use and it's intuitive. So it's easy to learn. Making an account is free and quick, and I'll talk about how to do that in a little bit. And also, this CAD software is very easy, but most CAD softwares do take a lot of time to learn. So after this tutorial, you may want to look into other CAD softwares, and we'll give you some tips on what to choose later on in the tutorial presentation. So in the chat, we just posted the Tinkercad link, so please click on that to open Tinkercad. And now I will share my screen. You guys see the, hold on. Do you guys see the Tinkercad screen right now?
Yes, we do, Rithvik.
Okay. So right now I'm logged in. I'll log out. So when you search up Tinkercad, it should be the first link and it will bring you to this screen. In the top right, you should be able to make an account. So if you have one, you can just click sign in, or you can click join now, and then you can just create a personal account, sign in with Google, sign up with email, etc. You don't have to, this will help you for the tutorial. So it's preferable if you can create an account, and we'll also try doing a CAD game after this tutorial. So please try and make an account. I'll sign in quickly and I'll wait a few minutes so you can just do that. And then once you sign in, you should just reach this page, and I'll just wait for you guys to come to this part.
Please put in the chat if you've logged in or have any problems so we can help you, Thanks.
So I'll just wait till, right now it's 3:42. I'll just wait till like 3:45. Or and also please type in the chat or message me if whenever you're logged in. Okay, if you can, you first have to click join now, because you probably won't have an account already. So you'll have to click join now.
Okay, yeah, so please click like join now.
So when you're at this page, you should click join now and then create a personal account and then just use some of these.
If you like, yeah, just sign
I'm
up.
using my school account, by the way. So if you have like a school account, you can just sign in with that. So and whenever you're done, just please put in the chat. So has anyone created an account yet, or? Okay, that's good. So I will probably start in a minute. So. Okay, I'll probably just start now. So hopefully once you've logged in, you see this page, and then from there you should just click create new design. So also does everyone see that, or did anyone get here yet? So please put in the chat if you're at this page, or if you need me to show you one more time how to do it. So did anyone get to this part, like to this screen, or? Okay, thank you for putting it in the chat.
Hey, someone tried to message me saying that they have trouble. Can you give it a few minutes?
I think most people are done. So I'll wait like maybe 30-ish seconds, but I'll probably start then because I don't want to keep everyone waiting. And it's okay if you can't get here yet. Yeah. So I'm probably just gonna start now. So first, this is like a CAD software. It's very simple one, like I said before. So in the top left, there's a cube, and this cube is essentially allows you to like change your perspective of whatever is on this work plane. So right now there's nothing in it, but let's say on the right there are shapes, and well, right now it's on shapes, basic shapes, but this is essentially just where you can drag stuff into your thing. And I shouldn't say drag, it's more to get something in here, you just click and then you click again and on your work plane, and now it's on there. And so now we have something, I can just look around this object using this cube. And when you put an object in here, usually there will be a few settings you can tweak. So this, like, for example, this radius thing, it will essentially just turn this cube into a sphere, etc. And usually different objects will have different things you can change. Like, for example, all you can change on this thing right now is this, like, is the steps. And now is a good time to mention this part. So steps, or in general detail, this is more an abstract concept, but when you're in CAD, or this is more so for modeling, but you generally don't want to have a bunch of detail. Right now there's like one object, but if you had every object cranked to the max and then you had like a bunch of objects, that could start to lag your computer. So generally don't want to do that, but it's okay because we have a few objects. And so now we have a few objects in here, but so now I'm gonna show you how to like more maneuver better. So this, under the cube at the top left, there's this thing called home view, and on the chat is.
One of them asked if they were using Autodesk, if we were using Autodesk Fusion 360 or.
Yeah, that's what we use for FTC. But right under the cube, there's this thing called home view, and that would just return you to this view. So if you ever get in a weird angle, you can just press that. And the right before home view, there's this full screen icon. So if you have an object and you want to focus on it rather than just zooming in or something, if it's like in a weird place, you can just click it and then click over here, and that will take you to the object. And you know you have an object selected when there's this blue outline around it, and that just means it's selected. And in addition, there's these plus and minuses, and they'll just like, you know, increase your zoom, decrease it. But you can just use your mouse for that, and you should be fine. Also, something I want to really call to note because it's important. This bottom circle is called switch to flat view orthographic. What that does is it's essentially giving you a geometrically accurate like representation of like your CAD. Like I've worked in Fusion 360, which is a more advanced CAD software. And what I've noticed is it's usually in this method, and I like this form, and I like it a lot because it's just generally more accurate in, yeah. So now we covered a lot of the layout and the how you move around, but now let's cover some of the basic functions. So as I said, you can just take shapes from the right and plop them into your work plane. But how do you like take away from an object? How do you cut an object? To do that, you just click on whatever object you want to be the cutter object, I guess, what you want to use to cut away from another object. So what I can do right now, it's solid, and to make it like take away, I just change it to whole. And that is done through clicking on the object and then changing it up here. So now this sphere is like, it will take away from an object. And if I move it here, it's now intersecting this object, but right now it's not really doing anything. I can still move this and it's not cut. To actually make this go through, you have to select both of the objects and go up here and click group. So to select both of them, you can click and drag, and that way you can, this selection box should appear and you can just select both of them. Or you can just click on this and then shift click, and now you have selected both of them. So whatever you do, whenever you have selected both of them, you just go up here and click group. And now, as you can see, the cut has completed. If you wanted to undo that, you could go up here, but usually you might want to undo it later on when you've already done a bunch of other stuff. So you can, in that case, you just go click ungroup. And a shortcut for that keyboard shortcut is Control-Shift-G. And then to group again, keyboard shortcut is also Control G. So Control G to group, Control Shift G to ungroup. Control G, and boom, it's there. Also, one thing I want to mention, you don't have to use these icons up here because Control Z, Control Y, the undo, redo, delete, Control C, Control V, they all work. So you don't really need to use this. And if you forget like the keyboard shortcuts, you know, they're there. And a lot of these icons generally have keyboard shortcuts. So yeah. Another feature I want to talk about is the align feature in Tinkercad. So let's say I wanted these two objects to be aligned, so just like straight together. I could just move it like this, but that's kind of annoying. It's pretty easy with one object, or sorry, two objects, but when you're dealing with multiple, that can be like a hassle. So what you can do, I can just select this object and then select this with either the click and drag or shift click. And then I can go up here to click align. So now with align, it basically opens up a vertical alignment, horizontal, and then the z-axis like alignment. So what I can do, I can click this if I want it to align it this way, but let's say I wanted to align it this way because I believe that's what I was trying to do. So then I can just click this and now they're both aligned. And so that's pretty useful if you want to like, it's just a fast way to do things rather than just hand place it. And I'll just read the chat quickly. Okay, I think we're good. So now that's the align feature. Another thing I want to mention is grouping. I know I just talked about grouping, how you can just use it to like make cuts go through. But another thing you can do with grouping is if you select both of them, you can essentially group two objects. And grouping two objects is just, now they're treated as one object. As you can see, I've grouped these two cubes and now I can just move them around wherever I want. And now they're basically being treated as one object. And then if I wanted to undo that again, I can just do Control Shift G.
Somebody asked for the align features.
The align feature is up here in the top right. It's where the grouping, ungrouping is. It's up here. It's this feature. And I'll just show that again. So I'll first ungroup these two cubes. And right now they're ungrouped. So if I wanted to align them, I'll select both and then go up here. And this is really where all of the like actual functions part of it is in Tinkercad. So then I can just click align and then I can align it with these. And yeah. So probably the final function I want to cover is mirror. And so mirror is kind of like, it helps you just essentially just mirror whatever you have. So I've selected both of these cubes and I can just click mirror again next to a line in the top right. And then I can just, mirror these things. Usually this is useful. For example, if you're creating like a character or something and you have an eye, you might want to mirror the eye so you don't have to create an entire new one. So that's just an example of how it would be used, I guess. So those are probably the most of the functions I want to cover. In addition, so right now I've always been on this basic shapes section. So there's a lot more sections, for example, text and numbers. And as you can see, it's just text and numbers. But the one of them and these other sections have different stuff. And if you can check that out in your own time. Another thing I want to cover is shape library. And this is just like community main creations. And a lot of them are really nice. So, you can use these if you want. Final thing is this shapes collection. So you see how right now this cube is ungrouped because I ungrouped it before. I'll really quickly group them and get this to go through. So I grouped these and the cut is loading now. So Tinkercad uses the cloud as like a cloud processing. So the benefit of that is that it can basically run on anything, but sometimes stuff can take some time. So now let's say I wanted, see this object I have created, it's not here. So let's say I wanted this to be an object that I can use. That's what the shape collection is used for. So first of all, select this object and make sure the blue outline is on it. Like that just means it's selected. And then just click create shape. And once you click create shape, you first have to name it. And I'll just name it the shape's loading here. So I think it'll take some time. Hold on, let me just try again. Yeah, so I believe it's loading. So just, yeah, I'll just name it like cube sphere cut, I guess. And then, well, I believe it's just loading right now. So yeah, web-based programs like this are often slow. Yeah, it's using cloud, so that's why. But anyways, as you can see, it's there because it just didn't load for me, but yeah, it's there. The final thing I want to cover in the CAD game, what I might want you to do is to share your design for me, and I'll explain more about how it works. But if you'd like to share your design with me, you can go up here to this collaborate feature, and you can click generate new link, copy link, and just privately message that to me, because this allows me to edit it. I won't edit it. I'll probably just view whatever you've created for the game to determine the winner, I guess. But yeah, that just remember in the game, if you'd like to share it with me, just use this. And yeah, so now just take like 3 minutes to just, well, a few minutes, just try and like digest what I just told you, just have experiment, I guess. And then after that, we'll just play the Tinkercad game, and you'll have to copy a design I've created, and I'll share that design to you in a few minutes. So just take some time, and yeah. In the meantime, if anyone has any questions about the Tinkercad, then I'll do that. I'll answer them. So yeah, just take a few minutes to just, well, probably at 4, right now it's 3:58 for me. At 4, I'll just start the CAD game. So if anyone wants me to show something again, they can also ask that. So if you want me to show maybe the grouping feature, ungrouping feature, how to cut an object, stuff like that, that would be a great time.
So Steven Zhang. All right, so the schedule for rest of today's camp is after we do the Tinkercad game, we're gonna show you like actual CAD software, so Fusion 360, what we actually use in FTC, and we're just gonna show you some of the basic functions. And after that, it's going that today will be over. The schedule for tomorrow is like we're gonna do building, so we're gonna talk about some building aspects. After that, we're going to do programming and some fun interactive, and we're also going to do a Java tutorial. So teach you guys how to do some Java. So I hope that answers your question. If you have any more, you can put in the chat.
Yeah, one thing I forgot to mention is that Tinkercad randomly generates names the first time you create something. So there'll be some like weird name. You can change it if you want, but yeah. But now I think I'll just start the CAD game. So I will share my screen. So right here, I've created an object, okay? And essentially the game is try and recreate it. Okay, I'll give you a few angles. So give you a minute to just look at it, and I'll keep it up while you're doing it too. So essentially I've created this object, and you just have to try and recreate it, and then you can just share me your design, and I'll try and determine a winner that way. But yeah, so I'll just give you, we'll probably do this for 5 minutes, so just try and recreate this. I'll give you 5 minutes, and then just try, and yeah. So yeah. And afterwards, I'll just show you how I did this. And also, the dimensions of this are 30 by 30 by 50 long. So I'm not really too worried about dimensions. Just try and make it look like whatever I have. And also, I think I may or may not have covered this, but you can just change dimensions of objects like that. So just click on these like black things and you can just change it, or you can just do this. And that's just click on the object and it should appear. So yeah. So at 4:05, actually, I think I'll give like till 4:07 because this may take some time, but you can just privately message your design. And also, if you want me to re-demonstrate a feature, like maybe grouping or something, you can just ask me and I'll do it. So is anyone having any luck creating this design? Is it going well or? Yeah, if you want any like angles, just, you can put in the chat. So you just have a few more minutes and just try your best. I'm not really too worried about, it being perfect or anything. Oh yeah, yeah. Here again, this is 30 by 30 by 50. I don't really care too much about the exact measurements, just try and make it look similar, because that's a lot. Generally in CAD, you're like, unless if it's like a part, then you're gonna have exact measurements, but sometimes you're generally just gonna try and just try and mimic something, or try and just create something using a picture or like stuff like that. And so it's pretty useful to try and do this. Yeah, is anyone finished and do you need more time, or because you have 2 more minutes, so please put in the chat if you need more time, or yeah. Okay, you can start sharing your designs with me right now. I can take a look at it. And by the way, don't be shy. If you didn't finish, that's okay. But you can just, again, the way to do that is just click up here.
Right.
And
Or they could like send a screenshot in the chat or something. They could just.
yeah, you could do either of those things. And then also you can just go up here, click this and collaborate, copy link up here, copy link up here, and then just privately message me that and I can take a look at it. Okay, so did anyone finish? Because I'm not really, no one send anything yet. If you need more time, just say or. I'm probably gonna show how I. Okay, I'm probably just gonna show how I.
Did anybody was okay? Somebody put in the chat. Yay. Okay.
Someone is asking how we send it, the link.
Okay, so you can either download it or you can just like just like you can just
To send a link, you go up here, click up here, invite people to this, and click. It's up here, and it's like this person with a plus, and you can copy link, and you can just send me a direct message.
Also, if somebody puts in the chat, please don't edit their design.
Yeah. So preferably you can private message me, so that way you know for sure.
Yeah. Okay, somebody else shared. Oh, Shayan Parvani, that's actually really good. I think the only thing would be to like just, you know, fix up the holes a little bit, but other than that, good. That's really good.
Okay, so I think people did a good job. It's a good first design for a lot of people. Like I've used Tinkercad before, and so that's why it's pretty.
Also, if you're not done with your design and would still like to share with us, even if the day's over, you can send it. You can send it to our Gmail if you want. I'll put the link in the chat.
Okay, so I think because of time restrictions, I can't look at a lot. I'll just really quickly run through how I made this. So I got the cylinder in here, and then I just changed the dimensions 30 by 30. Let me do that. And by 30. And you could have done that by just, you can, do that, or just, I think I forgot to mention this, but I think a lot of you figured that out. But and then I just changed the height to match. It was 50 feet, 50 tall, and I don't really care about dimensions. Again, I'm more so care about you trying to create it yourself. And then to make this cut, because of time restrictions, I'm gonna have to rush, but essentially I just created a cylinder, made it slightly smaller and less tall, and I made it a hole and used the grouping function, cut this part away. Then I just created the, I used the round roof thing and just had it cut here. And I used the align feature to align these two so it would be perfectly centered, essentially. So that's how I created this. If you weren't able to do it, that's okay. That's totally fine. I think a lot of people did a good job for their first time. I think now we'll get back to the presentation. So before, I think we,
In the chat, put if you want to break or not.
sorry.
Okay. I think we can skip the break. It's like almost done anyway. So
Yeah.
if you need a break, you can take a break.
So we're going ahead without the break, right?
Yeah, just carry on.
Now we're going on to more advanced CAD software, specifically Fusion 360. So our team has used Fusion 360 and Autodesk Inventor in our season, okay? So today we'll only be showcasing Fusion 360, okay? So however, depending on what your computer hardware you have or like what needs from the software, that may or may not be the best choice for you or your team, okay? So in the chat, we will put a link to Game Manual Zero, which is a great resource for rookie teams and players as it contains a lot of FTC information. So under its robot design section, there is a CAD subsection, and that will detail the pros and the cons of these softwares so you can decide what's best for you or your specific team. So I will say that if you're a beginner, I would recommend Onshape as it's cloud-based like Tinkercad, meaning that it can run on your browser and there's a lot of resources available for it. That'll make it very easy to learn. So these are just a couple of our Fusion 360 CAD pictures. So I'll just briefly explain a couple. So on the far right, you see a design for a robot that we had, okay? And it's made of chassis, and it wasn't fully complete as you can see, but it's an idea that we had. And the two purple pictures are number plates that we have 3D printed and were currently using in our actual robot. So Fusion 360 is a more advanced CAD software that is actually used in professional fields. It allows for much more complex designs in the 2D and 3D world. As you can see and illustrate from the picture, this is something that you simply wouldn't be able to make in Tinkercad. So not only can you make and design things, but you can even create realistic renders and make simulations. In this class, we'll be covering the basics of sketching, modifying, combining parts, but you can learn more on your own. So sketching in the context of FTC is often used for making 3D printable parts or for making something using a CNC machine. The nice thing about sketching is that it's relatively universal, and sketching between different CAD softwares is like universal. So Fusion 360 allows for you to sketch using many different functions such as lines, rectangles, and circles. Then you can adjust these using a variety of modifying functions. So now I will be showcasing some of these basic functions to you guys. One second. So can you guys see this?
Yeah.
Yes, we can.
So here we have the UI, or I guess like the space that you'll see when you get into Fusion 360, okay? So right here on the far right, you have your data panel, okay? So this data panel right here has your list of projects, and inside of these projects, you can have specific designs or versions of designs in these projects, okay? So for the purpose of this class, I created a project called FTC class. We'll just leave it like that. So right now, we're going to create a new design. And right now, we have a save function. And we're going to title it practice 1. Okay. Let's just call it practice 1 and save. So here is, we're gonna start making our first step. So let's just hide the data panel as it's not necessary right now, and right here, okay? And let's get to work. So first, you have the create sketch function here. So first we want is pick a plane to sketch on, okay? So we're just gonna start off with this plane right here. I'm gonna start showing some of the basic functions, okay? So say we want to create a simple L, okay? So let's just start off by making a simple L. Just make it 50 millimeters, okay, 50 millimeters, and we'll make it like that. Sorry. Line. And we're just going to make a simple L. Okay, then press enter. Now, this is just a simple L, okay? So that's the thing. Many of the functions, as you can see, are kind of self-explanatory, okay? Creating lines will just create lines, rectangles create rectangles, circles create circles, and etc. Okay? So now let's just go back to this line. So now, say we don't like it, okay? So now we have an L. Say we want to make this the vertical side longer, as that's what L's have. So we can do that by creating a line, okay, and extending it, like just like this, okay? It's like that point, this point. Press enter. Now, what you know is we have this L, but there's a problem. We have Fusion is viewing these as two separate parts, okay? And this can be a hassle when we start extruding these and giving them actual like weight later on. So what we're going to do is we're going to select the modifying function and select trim using the T trim or T, okay? I'm going to select trim and we're going to trim this and enter. Now again, now we have our L and it's viewed as 1. We have one small problem that really wouldn't be an issue, but can be sometimes. So right here, you see that this line isn't a perfect line. It breaks up right here. So we can fix this by, again, selecting trim. And then, as you can see, it's auto-clicking these, Fusion 360 auto-clicks these two parts. And we can trim those, keep that there. And then we can select the extend command, okay? Now this will extend these two lines to match these 2 points, okay? Center, and we have our L, okay? When we click finish sketch, here's an L. And what we're most likely going to do is we're going to extrude this L. So the L is already pre-clicked, extrude it, and now we have our L, okay? Now let's just keep it as a component for now. Okay, so now we have our L, as you can see. So now I'm going to show you some of the more functions in sketching. So say we want to actually, let's hide this for now. Let's create this. Let's title it actually as L beam, I guess, L beam. And we'll keep this. Now let's just hide this away. Now, right here, say we want to create a box, okay? A box like this one, okay? A rounded box, and that, unlike this one, it won't be as fancy, but it'll have a cap, and it's a simple rounded box, okay? So now, you get back to Fusion 360, okay? And to create sketch. We select our plane as we wish, and we get to work. Now, again, we're going to make sure to select the we're going to select create a 2-point rectangle. So what this does is essentially you put another 1 point and you pick another point and it creates a rectangle. Okay. So again, select it. Let's make this 70 millimeters by 70 millimeters. Okay. Now this will be the outer edge of our box. Now we can fillet this. So what the fillet command does, specify, is it rounds corners, okay? So we can select each corner. I'm going to want 15. Let's just make it 10 millimeters. Again, many things like this is automatically done by Fusion 360, okay? So we can select each of the corners. Center. We have the outer of it. But we need some breadth to this box, okay? Because right now, if we extrude it, it's just a square slab, okay? So now we're going to create another rectangular, square, sorry. Go here, press enter. Now our box, we can click finish sketch, okay? Now, as you can see, we have our box. So now what we select is extrude. Now, we don't want to select the middle range for now, but we're going to select this edge right here. And we can extrude it. Let's say we again can pan out and 70 millimeters. Make this a component, press OK. So now we have the outer shell of our box, okay? But there's one slight problem, which or two problems really, which is that there's no base, and additionally, we have no cap yet. So let's first get to work on the base. Again, select create sketch, and we're gonna select the plane, okay? Again, create 2-point rectangle, 2 points, press enter. See, that's the thing. Very self-explanatory. Finish sketch. We're going to select extrude. Again, we're going to extrude this beam. Let's say 10. Now, an interesting thing that you might have noticed is before Fusion 360 would often make this an autoclave as a new body, but this time Fusion 360 has correctly guessed that I want to make this into one singular part. Okay, so it is selected and made this as a joint, or as this joint. So what that means is when I finish this command, it'll make it join into this component and make these two pieces as one component, and won't view them as two separate things. So got this. Let's just make this 5 millimeters. Okay. Okay. Now it's set to work on the final piece of our box. Okay. So this time, watch carefully. Instead of selecting the plane on the bottom as previously, we are going to select the plane on the top of the face of the box. Okay. Now we have this. Okay. Now what we're going to do is we want to make a box. We again select. Now instead of just selecting the same corner, we want to make it bigger. Okay. And it has to extend over the box. Okay. We want this cover just like that. Press enter. Finish sketch. Oh wait, sorry. Now we want to fillet this. Again, select fillet. Millimeters. This is the pan. This hand is called a pan function. It lets you pan around your sketch or designs that you're making. Okay. So we can select fillet, this corner, this corner. Press enter, and started making the box. Now, again, select extrude. Like that. What you might notice now is when I select extrude, it becomes a hassle when I want to extrude the whole thing. So what I can do is I can hide this component, okay? And then I will simply select this by simply dragging my mouse, holding my mouse and dragging it across my screen. Then select extrude. We can show this box again for reference. And let's just make it 10 millimeters thick. Now it's selected joint as that seems, at least to Fusion 360, that seems like a reasonable thing. But we really don't want this as we don't want it as one body. So we'll just keep this as a new component. And then press OK. Now, another thing that we haven't done is we need to name these. Let's just call this main box. And we'll call this the cap. Just cap box. Or cap box. As is the cap, or like the thing that covers the box, basically. Okay. So now the final step and thing is what you notice is this is just seen as one main slab, okay? And that's really not gonna help. It can just slide off. It doesn't fit with the box nicely. So what we're going to do is we're going to select the bottom right here. And now what we want to do is we want to create a sketch and then extrude it into the cap, giving it some breadth for the cap to fit onto the box. So again, we select create sketch. And this time, so we're going to select the bottom of the face. Let's hide this. And we want to make sure to select the bottom of this component. Again, we can have this back for reference. Create a 2-point rectangle. Can't see this very well, but match the corners. Press enter. Fill it again to 10 millimeters. 10 millimeters. 10 millimeters. Now, one thing I haven't shown before is that when you adjust how much you're filleting in a shape like a rectangle, it's going to fillet equally for all of them, okay? So before it was 10, if I select 25, all of them will be filleted by 25 millimeters, okay? Or rounded by 25 millimeters. So go ahead and keep it as 10 and go and press enter. Now, going to hide the main box and select Finish Sketch and select Extrude. Now we select this face, and as you can see, it's on new body right now, currently, okay? As right now the plane, it wants to point down. But when we move this back up, okay, and cut into the shape, Fusion 360 again correctly guesses that we want to cut and cut into this component. So let's just cut it by about half or 5 millimeters and press OK. So now it's been cut in, and you can see that from here, okay? So now let's create this box. Let's show the main box. And final step is to make it fit snugly, we're going to select M or Move, which is under the Modify tab. It's called Move. Copy M. We're going to select a point, let's just say the middle, and let's shift it down by 5 millimeters. It's okay. And just like that, we've made our box. Let's save this for now. Yeah. So now we're going to transition back into the slides. Yes, as Smita said, if you have any questions, please put them in the chat. Rithvik can answer them, as he also has a vast knowledge of Fusion 360. So combining parts is the next thing we're going to learn. So combining parts is one of, if not the most important part of CAD, okay, especially in FTC. So combining parts in Fusion 360 is often done in two main ways. This is done through the Combine function under the Modify tab and the Joint function under the Assemble tab. Okay, as you can see, I've circled them. So now I will demonstrate these two functions and show what they are really about. We have this here. Let's open a data panel. Okay. So I can show you real quickly how the combine function works. So what you notice is the combine function is you select two parts, okay? So let's just move this randomly, okay? Let's just move that there randomly, there. It's just random, okay? And what the combine function does is you select two components or two bodies, okay? And all it does is it joins them. At least that's the default setting. It can also cut and intersect as we wish, okay? So for joining things, it isn't really nice, as it won't put two components that you want flush against each other, okay? And it's really only used for cutting and intersecting components, okay? Right now that can't currently be done, as they aren't really, touching. So we'll just cancel. So now I'm going to let's go back to FTC class, and I'm going to open joint practice. I've created this ahead of time, and it's one where I'll show you joints. Now, this is the preferred function and the one that most people use when joining and trying to make two components be flush against each other and fit snug and nicely, okay? So as you can see right here, I have this design that we actually thought of it was supposed to be a kind of conveyor belt, okay, that would have belts on these small wheels I can see. So here under the Assemble tab, we have the joint function. Press J, okay? So let's demonstrate this. Now, before we do that, actually, I want to get this component. So anyway, sorry. We're going to select this. Okay, here's this. And I'm going to ground this beam, I guess. So I'm grounding this because I don't want this to move, okay? I'm going to select ground. So you can see we've grounded this component. So now what we're going to do, select J as the joint command, and we're going to try and make sure that these are properly flush against each other. How that's going to work is, it's explanatory, self-explanatory, but we're going to select this tab, okay? And now we have the space, and we need to select a point on this, okay? So because of how it's structured, we want to point that they, we want to point that they share, okay? So as you can see, we notice is that right now we have a intersection between this point roughly around here, okay, on this line, and the same one on this beam. So what we're going to do, going to make sure, we're going to select this face, okay, hold control, and this will make sure that we are able to correctly and select a snap point, okay? Select a snap point, and we select, again, select the same snap point over on this side, okay? Again, let me just, one sec. I'm going to go to home to make it easier for me to go back into position. And we're going to select this face right here, okay? So we're going to make sure to select this point, hold control to make sure we get the snap point, and select snap. As you can see, now these two components have meshed perfectly with each other and now flush against with each other's bodies. Press OK, and we've created a new joint. This joint will now be filed under these joints, the joints folder. Okay. Now I'm just going to keep this grounded as I'm going to do 2 more demonstrations of the joint function. Okay. Actually, never mind. I can unground this. So now we're going to join. Say you want to join this axle over here. Okay. This axle, this bracket, I guess. So we're going to select we can just simply select the bracket, okay? Simply select any face. What it does is it's going to highlight where it is. So again, we're going to select this, and then we're going to ground this as we don't want it to move. Okay? And then I'm going to select J for the joint command. And let's just say we want to select a point. Let's just select that point right there, as it's easy to see. Or sorry. J for the point. And we're going to select, make it, let's just select right there, that face right there. Now, it's going to be kind of tricky, but we need to make sure that we can, okay, there we go. Now, we're going to select this face right here. So this is the face that we want to be flushed with. We press Control, okay? As you can see, now instead of just randomly moving about, it'll go to snap point specifically, okay? Select the snap point, and just like that, it's aligned. Okay. Now, say we don't want it to go all the way in here, as that would actually cut into that would make it a bit too short for this one. Okay. So let's just move it a bit back. As you can see from here, it's pretty nice fit with the other edge. Okay. Let's just press OK and leave it like that. So the final demonstration of the joint command, okay? So now, let's say we want to get one of these wheels, okay, sorry, pulleys, flush with this, okay? And now I've already spaced these out, and when I was making the design, I spaced them out equally, okay? And I want it to be aligned with the axle properly. I also don't want it to move against the axis of the axle, okay? So what we can do is you can select Create Sketch. and we select this plane right here. And one of the functions I didn't cover yet is the point. We're simply gonna make a point, or we can even make a line. Let's just select line, as that's just easier and more noticeable. Gonna select line and make sure that it's flush against this one. Okay, create a line. Just like that, we created a line. Backspace, and we're gonna finish sketch. And as you can see, the line is right here. Now, what we do, we wanna get this axle, and we want to ground this one. Okay, the axle now has to be grounded. You can unground this bracket. Now what we do, like again, J for the join command. Select top. Okay, there. Again, press Control so it isn't just randomly floating about. So it goes to the stop point, press. Okay, and then we want to do the same thing here. And because I've done this, as you can see, it's holding the position, and I can make sure it's properly that it doesn't move on this axis. And press J here. Just like that, it's flush with that. And we could repeat this process for all these wheels to make them also flush with the axle. So thank you for holding on with me. And go back to the presentation. Okay, so now I'm going to cover a very important discussion, a very frequently asked question and discussion, okay? And that is, what is the difference between components and bodies, okay? So now there are two main differences between a body and a component. And the first one is illustrated in this graphic that I've made, or graphic that I've, I guess, found. So bodies can be thought of as a single part, okay, a single cube, okay, and that can be thought of as what a body is, while a component is multiple bodies and multiple sketches, decals, and many other things, okay, and it can be thought of a container of many things, okay. And so the second difference is that components are bodies that also have their own origin planes. Now, this is something that isn't really important, at least until like you are a very advanced CADer, and something you shouldn't really worry about. So if you have any question, please post them in the chat or speak up.
If anyone wants us to show any designs or anything that we made, then we could do that. But does anyone want to see that? Or well, we're already going a little over the time.
Yeah, I think I'm not falling too far behind. I think we can now go to the final thing of this day, which is our Kahoot. So I think Arnav has a Kahoot, and he'll handle that.
Yeah. So let me share my screen. Okay. Oh yeah, wait. It was here. Okay. So this is the Kahoot join link. I'll start the Kahoot at 4:43. It would be great if you turned off your cameras for this, so there won't be any lag and we can focus on the Kahoot. Okay, I'll start in 4:43, so just a few more seconds. In the chat, if you're still joining, please stay so I can wait a little bit. Okay, I think I'll start.
So I think this is very I guess polarizing kind of question. I mean, get it. So while to look at your look, I'm gonna adjust the of course no one got the first red and blue wrong, but on to see the reason why to look at how your robot look is isn't really the right option is while it's important and it shows how you look, okay, it's really only one half of the thing, okay. It's also to remove any kind of possible headaches in any future possible kind of headaches in the design process, and so that's why yellow is correct.
Also, also another reason that the green isn't correct is because I don't know if we've said this earlier, but CAD designs are kind of like a guidelines. What your CAD design will look like is not what your final robot will probably look like unless if your team is super advanced and dedicated to CAD. If you look at our own CAD design that we posted in the chat and you compare it to a robot on YouTube and stuff, they're barely anything because CAD is just a guideline. It is not the final thing. Good job on.
Are you in the Kahoot?
No.
Oh, okay. So someone's acting as you. Okay. So yeah, CAD isn't necessary for successful robot at all. Okay, you can completely build a robot, as I said previously, ground up without any CAD. Okay, it's recommended, but not necessary.
Yeah, and also because the way when you're actually, if you just go directly into building, which you could do, it's like when you make a mistake, you basically just have to take apart whatever you just worked on and fix whatever that was. And so when you CAD, you can create more complex designs because you don't have to worry about making a mistake because you already have it pre-planned out. And so that's just why. But it is for it, you don't really need to do that, but it does help like a lot. So
And Anna's still on top. Good job.
I think we might have actually not covered this. That is, it's okay if you get this one wrong.
No, I think we did.
yeah, so this was my fault. I didn't cover this that much, but at first glance, it's B because you can import stuff into Tinkercad. I didn't really cover how to do that, but it's just in the top right. But 25 megabytes is not a lot. So a lot of the complex like components, because if you're trying to CAD robots, like the reason you can't use Fusion 360 and you have to use better softwares is because first of all, there's more features in better softwares, but also it because it's only 25 megabytes is the max, you can't import like motors. Like a motor, I think, is like way over 25 megabytes. And our full robot design, I think, was like, I don't know, like 200, 300 megabytes when we are doing this. And so you just can't do it. You may be, and other softwares are just generally better. So yeah.
Oh, looks like Elon Musk's son has appeared. New challenges have approached.
Anna's still on top. You can leave now if you want to. This is just fun. Just make sure to come back tomorrow at same time.
Yeah, bye guys.
Yeah, so it is, C or the circle. Sorry.
Arna, if you can skip.
Okay, so for this one, we covered this before we went to the Fusion 360 part, but the reason we recommend Onshape is Fusion 360, like one of the reasons we use it is because we just discovered that one first, and so we used it first. But we think Onshape is better for beginners because it's cloud-based, so if you have a really bad computer, you can still use it. Oh, hold on, and also just because generally like Fusion 360 like it's good. It's a good software, but Onshape I think is just easier to learn. So
Yeah, Yeah. So first one, the first thing that we the first, I guess, major difference and the one that's important is that, again, components are like boxes or boxes or containers for multiple bodies and like many other things. And the other one is that components are bodies that store their own origin plates. Looks like Candy has been to first.
Elon Musk's son is still there though.
And so whoever's like use my name, please stop.
I don't think that person can change.
Wait,
right
that
now,
wasn't you
though.
the whole time? Wait, that wasn't you?
No, I'm not playing the game.
Oh, I thought it was you.
There's somebody.
Ding. So yeah, okay. So this one. So the joint command is the preferred function for assembling components in design because as you showed previously, the joint command actually makes sure that components in a design are flush, okay? And another dead giveaway, I think that another thing that we didn't cover, but it's also a dead kind of giveaway, is that this is mostly focused on components, and components are often done on joints, as the joint command simply doesn't work on bodies, okay? So for components, nearly 95, maybe really 98% of the time, people are going to use the joint command for it.
Candy's still there, but Elon Musk's son is still there too. Yes, everybody got the correct answer. Elon Musk's son is right up there. All right, this could make Elon Musk win.
This is a hard question.
Yeah,
Really
let's
be
see.
paying attention to this. Take your time. And pay attention. These are the labels and not the actual functions. So yeah, the joining and combining functions are listed under assemble and modify. So under the assemble command is where you have joints, and under modify is where you find the combine command.
All right, let's see if Elon Musk's son took.
Or else probably advanced.
Oh man. Good job. Good job.
Good job, Shayon. You officially won the KAHOOT.
Good job.
So I guess that this wraps up day 1 of our camp, and we hope to see you tomorrow.
Yeah, tomorrow at the same time, look on, so basically we've sent all of you a Hangouts invite, but like not many of you have been on it, so just make sure that you check, because there it's gonna have all our updates. Also, I'm gonna put our newsletter in the chat, because in there we're going to put all our updates for the camp. So make sure you check it tomorrow to see if anything changed. Goodbye. We hope you
And
have
also, we'll email you if
Yeah.
just in case.
yeah, we're going to
Bye,
send an
guys.
email.
So you can email us if you have any questions.
Yeah, and we're gonna send an email to you guys for confirmation. So goodbye and see you tomorrow.
Yeah, tomorrow we'll
Bye,
cover
guys.
building and programming.